Work done by a spring force. Work done by a spring force. So we have already saw what is the work done by a constant force, what is work done by the gravitational force, what is work done by the applied force when the object is lowering and lifting. So in this section we are going to find out work done by a spring force. So this is the one spring is here, x is equal to 0. Now what I am going to do, I am going to build the block in this direction. So I am going to build the block in the x direction F. What will be the 2 in the spring force? This force is the same force is acting in the opposite direction to my applied force. So the spring force is acting leftward direction. My applied force is acting rightward directions. This is according to the Newton third law. Every reaction is equal and opposite reaction. If I am giving the applied force this direction, spring force is acting this direction. If I boost the bull in rightward direction, what will happen? This is x is equal to some d. So if I boost the bull, boost the block from this distance to this distance, if x is equal to minus d, my force is applied force is acting this direction, leftward direction. Spring force is acting this direction. So this is F. Spring force is acting rightward directions. So many experiment they have find out the force the force F is equal to minus k into d. So minus k is nothing but spring constant or force constant, d is displacement. But so many experiment the scientists are find out the force between the spring force between the distances F proportional to minus k into d. K is nothing but spring constant. So this is called Cook's law. This is called Cook's law. Cook's law. So this is important. If F is equal to minus k into d. So this is called spring force. So now we are going to find out work done by a spring force. So work done by a spring force. So spring force is not a constant force. By using the distance is decreasing, the force is increasing. If the distance is decreasing, force is increasing. So this is a conservative force. So we can't apply the formula F is equal to W work. We have already signed FD cos theta. This formula we can't apply in these situations. So what I am going to do, in the displacement, what is the small displacement? In the small displacement, what is the I am considering constant force. I am splitting the distance to small distance. So in the small distance constant force, I am going to apply this concept F into d cos theta. Then finally I am going to apply sum of all the forces. So work done W in the small section, but W is equal to F into Fj, F into del x. So in the small distance, the constant force is constant force F into del x. So what is the summations of the F? Initial to final, but W is equal to integral initial to final F into dx or del x. So what I am going to do? So F into F is equal to minus k into d. So W is equal to integral x1 to x2. So minus k into dx, kx into so dx. So if we integrate, what is the work done? W is equal to so minus 1 by 2 minus kx 2 square minus 1 by 2 kx 2 square minus 1 by 2 kx 1 square. This is the work done by the spring force. If kx x1 at the initial point the particle is 0, then we can write W is equal to 1 by 2 kx 2 square, kx 2 square. So this is the work done by the spring force.